This is using a lot in the poultry industry. Before and after carcass killing, we'll mention about the poultry processing in examination 4. They're using this agent a lot. It has a very good impact to killing bacteria before and after the chilling process. That's called the CPC, the acronym. Okay, with regulation. Okay, be very careful. Does not mean any of the antimicrobials, antibiotics you can use, especially antimicrobials. First of all, you need to be approved by EPA, United States Environmental Protection Agency. We talk about this all the time right now. Some people say we want to get rid of that agency because of the climate change. Some people say we have to keep it because of global warming, blah, blah, blah. But anyway, it's existing in the Washington, D.C. It's an agency regarding sanitizing registration. They're going to look for antimicrobial efficacy, chemistry components, toxic, and the technical literature and labeling. They want to make sure the sanitizing and the sanitizer antimicrobials, those are environmental friendly. How about they use on the food surface? That has to be approved by FDA and USDA FSIS. They're using anything coming from EPA to have label instruction how they're going to use. So anything approved on the food contact surfaces has to be approved by both of them, typically for FDA. This comes out, the sanitizer approved by FDA since 1996 for all of them can be used. So we want to go over them briefly. Chlorine, you know that, Chlorix, $5, 1 gallon. I said it's very effective. But be careful, it's not 100% chlorine, it's usually 5% sodium hypochlorite. Chlorine, the bad thing, is going to be effective with organic matter. So make sure the beaker, the container, has to be clean. Okay, people say, I want to have something which is not really sensitive to organic matter. Then there comes out chlorine dioxide. However, the chlorine dioxide is a gas, so it's difficult to control. That causes another issue for human safety. Iodophos, this is like iodine. This is a good thing for sanitizing. We know whether you sanitize or not because it has brownish color. Contrary ammonium compounds, we call it quartz. This is one widely used in the meat industry or in the lab surfaces because it's curing around 5 log. Acid, carbon oxyacid sanitizers usually used to curing or inhibit acid-resistant bacteria. But be careful these two sanitizing. It's too low pH, very severe corrosive lots of the time. Perioxyacidic gases components, hydrogen peroxide and the perioxyacidic acids, they are causing oxidation of the bacterial cell. Right now, there is a company has a one reagents combined with perioxyacidic acid and hydrogen peroxide called Sanidate 5.0. They use widely in West Virginia area, typically in Preston County Workshop, which is in Reidsville, West Virginia. So if you have a cucumber, you have a squash, you see those selling at farmers markets, some of them washed with a mixer of hydrogen peroxide and perioxyacidic acids. I introduced you these, gave you a very brief introduction, but the bottom line you need to know. Whenever you prepare sanitizers, you need to prepare at least 2. Because if you are keeping using one sanitizer, the bacteria very easy to become resistant. So you need to prepare at least 2. Okay? We go over real quick for these. Phenolics. This one is the first antibiotics, first antimicrobials used in the history. But don't use this, but not use this one anymore. Because it's a disagreeable odor, smells really, how we say it, really harsh, and it causes severe skin irritation. It's a long history, the first one we used, but we don't use that too often anymore. Because it causes severe skin irritation. Alcohol. there is a basic knowledge behind this you should know. 100% alcohol is not going to be effective. You need more or less for some water. So, we always prepare 95% or 75% alcohol. This is the common sense. I hope everybody, after this class, you're going to tell your parents, tell the friends, if they don't know, never use 100% alcohol. To sanitize the surface, it's not going to kill bacteria. I did that 10 years ago when I worked in the company. I used a microscope. You see the bacteria is tumbling there. It's not going to kill. Once you add water there, it will be killed. Why? Because alcohol will be completely reacted with lipids. If you have 100% alcohol, they're going to be reacted with lipids. Don't have anything for the other structure of the bacteria. But when you put water there, they go everywhere. Very simple reason. Never use 100% alcohol. It's not going to affect it. More or less, you have to put some water. Okay? Now, the denatured protein possibly dissolve membrane lipids. Contrary ammonium compounds, we already mentioned, it's killed most of the bacteria, not in those for tuberculosis. Why we use it often? Because easily to prepare, inactivated by soap. And be careful, don't use hot water. That's another common sense in West Virginia area is have to be very careful. Don't use well water and pond water. Those are hot water. What means hot water? Calcium and magnesium has been more than 150 ppm. What is the way? The easiest way to do a hot water become soft water is boring. Is that right? But nobody gonna bore in the pond water. So don't use pond water. Use municipal water because pond water is hot water. Hot water used to prepare, lots of the antimicrobials will be inactivated because of the calcium and magnesium is there. Sometimes will be effective. Okay. I think our drinking water, the municipal water, the calcium has to be less than 25 ppm. If you go back to check, I may miss a number, but has to be below a certain level. Aldehyde, formaldehyde, glutalaldehyde. What they use for? This is what we said, antisepsis. This is used for to antimicrobial tissue culture, animal bone culture in a museum. They don't use for human being or they use on the food contact surfaces. So formaldehyde using in the museum. So we have all these chemical antimicrobials and the physical control. We could do biological control. A good example is lactic acid bacteria. Lots of the time, we're using lactic acid bacteria survive to spray on the surface. The bacteria will be killed. The harmful bacteria will be killed because the biocene will generate from the lactic acid bacteria. We also do a bacteriophage lysis. So we can isolation bacteriophage from the soil. What is bacteriophage? Which is a virus can invade the bacteria. They could be very friendly, which is we call it a template phage. It could be called a lysis. We call it a lytic phage. Okay? And we also could use bacteriocin. That could come from different type of the bacteria. So just to give you an example of the biological control of microorganisms. Okay, so here we end up with all this section for the control. We will have a couple of questions maybe come out from this section, especially the definition of sterilization, disinfection, sanitizing, and what is D value and Z value. Those you should know, okay? But majority of this set of exam will be all these passages related to human disease. So you go ahead to do the practice question by yourself, and next Tuesday we will go over it more systematically. Okay, so that's all we have to do.